Good day, class. This is Sir Kenny with another topic in STM006 or General Chemistry 2. We are going to discuss module number 15, which talks about explaining entropy and the second law of thermodynamics. Now, before we delve in, let us have our lesson objective. So, by the end of this lesson, you can say that yes, I can determine if there's an increase or decrease in entropy in a chemical reaction. Before we delve into our main topic, let us have a discussion on spontaneous processes. So kapag sinabi natin spontaneous processes, ito yung reaction na kung saan nangyayari siya on its own. And it can happen without anyone's intervention or even without applying work in a system. Samantalang kapag sinabi naman natin non-spontaneous, ito yung process na kung saan nangyayari siya kapag nagkaroon ng intervention or kapag nag-apply ka ng work sa isang reaction. So, an example of this spontaneous process is the rusting of iron. Kapag yung iron nail, iniwan mo lang siya for a few days out in the open, it will react with the oxygen found in our atmosphere. And with the reaction of iron and oxygen, magkakaroon tayo ng iron oxide or the rusting of iron. Now, there was no any form of work done on the object, pero nagkaroon siya ng chemical reaction, which is the rusting. So that is spontaneous. It happens without intervention, without use of work. Kapag sinabi naman nating non-spontaneous, ito yung kailangan na mag-exert ka ng effort, mag-apply ka ng work para magkaroon ng reaction. Kailangan merong intervention. So for example, doon sa rusting ng iron, gusto mong tanggalin yung rust. So in order for you to do that, kailangan mo mag-apply ng effort, mag-exert ng work para ma-reverse or ma-revert back siya sa kanyang original state. So let us have a few examples on determining if a reaction is spontaneous or non-spontaneous. So number 1, flow of water down a hill. So do you have to exert effort or work in order for the water to flow downwards from a high place? So number 1 is spontaneous. It happens on its own. Number 2, a roaring bonfire. Malakas ang liyab ng apoy doon sa bonfire. So since hindi ka nag-exert ng effort para magliyab pa yung apoy, then this is spontaneous. Next, a lump of sugar dissolves in water. Kapag naglagay ka daw ng lump ng sugar sa tubig, kusa na siyang matutunaw. Even without your intervention by introducing heat or by stirring the mixture, kusa na siyang matutunaw. So this is an example of spontaneous process or reaction. Freezing water using a freezer. Maglalagay ka ng tubig, ilalagay mo sa freezer, nagkaroon ng intervention, nag-apply ng work. So that means this is non-spontaneous. Purifying oxidized gold. So yung gold daw na-oxidize siya. Now we have to remove the oxygen content dun sa oxidized gold. Now, since magkakaroon ng intervention, mag-apply ng work, then that means number 5 is non-spontaneous. Okay? Now we go to our main lesson, which is the second law of thermodynamics. Now, in our previous discussion about the introduction of thermochemistry or the chemistry of the study of heat and its flow, diniscuss natin ang first law of thermodynamics wherein it states that energy cannot be created nor destroyed. However, it can be transformed from one form to another. So that means the total quantity of the energy in the universe stays the same kasi hindi nadadagdagan, hindi nababawasan. Nagkakaroon lang ng transformation from one form to another. Example is from electrical maging chemical to light or heat energy. Now, the second law of thermodynamics is about the quality of the energy. So dito naman ang focus natin for the second law of thermodynamics is the quality of the energy, wherein kapag ang energy daw ay na-transfer or na-transform, some of it is wasted. That is because in nature, according to the second law of thermodynamics, there is a natural tendency of any system to degenerate into a more disordered state. So mas gugulo daw, unti-unting gumugulo ang mga objects within the universe. For example, sa bahay, nagpatayo ka ng bahay, malinis. After a few days, gamitin mo man yung bahay o hindi, unti-unti magkakaroon ng dumi. So that is the natural order of the state. lalong gumugulo habang tumatagal. Now, mag-exert ka ng work or ng effort para linisin yung bahay. So, dahil nag-exert ka ng effort para linisin yung bahay, nabawasan ng konti, but it will never be the same as kung ano yung bahay nung bagong gawa pa siya. Yung linis nun, hindi na the same doon sa kung ano yung originally na linis ng bahay. Yung baso, nabasag. Now, because that glass or that cup is too precious for you to throw out, ang ginawa mo ay dinikit-dikit mo na lang siya. Now, yung pinagdikit-dikit mo na baso na nabasag, it will not be the same as the baso na kung saan hindi pa siya nababasag. Na-compromise yung kanyang quality, na-compromise yung kanyang sturdiness. So yun ang sinasabi ng second law of thermodynamics. It will go from an ordered state towards a more disordered state, even without the intervention. Now, when we speak of disorderliness, entropy is the measure of disorder, and it is given the symbol S. S stands for entropy. The units of entropy are joules over mole Kelvin. So lahat ng mga substances, ang kanilang entropy value ay naka-indicate as joules over mole Kelvin, where J stands for joules or the energy, mole stands for the amount of substance, K is the temperature. Now let us study the two images. So the first one and the second one. On the first one, the pattern is regular, it is ordered, and because of that, mababa ang kanyang entropy or hindi siya magulo, hindi siya disordered. On the second picture dito, you can see here na mas pakalat-kalat yung ating mga particles. So therefore, we can say that the particles are disordered, they are randomly arranged, and because of their disorderliness, mataas ang kanilang entropy or the measure of their disorder. Now, let us take into consideration the different states of matter. Now, we have three common states of matter. We have the solids, the liquids, and the gases. So if you're going from solid to liquid to gas, habang pumupunta ka sa liquid, habang pumupunta ka sa gas, we have already discussed this, yung mga kanilang arrangement ng mga particles ay nababago. Ang mga solid, yung arrangement ng particles nila ay very uniform. They have little to no movement. Samantalang sa liquid at sa gases, meron silang capability to flow. Pero pinakamataas ang fluidity or to be able to flow sa mga gases kasi yung mga particles nila ay sobrang layo from each other. Now, sino sa kanila ang may pinakamababang entropy? Of course, we are going to assume that the solid states are the one with the lowest entropy kasi naka-arrange in an orderly fashion yung mga particles nila. Samantalang sa gases, sila yung mataas ang energy, sila ang mataas ang fluidity, we can expect that the gases will have the highest amount of entropy because of their high amount of fluidity. According to the second law of thermodynamics, nature is always proceeding to a state of higher entropy. So how do we determine if the entropy is positive or bumaba yung kanyang order or nag-increase ang pagiging disorderliness niya, or kung ang entropy natin ay negative or nag-increase in order or bumaba ang disorderliness. So there are two ways. Number one, visualize the reaction kapag ang ginamit ay word equation. Or you can check the chemical equation kapag chemical equation ang ginamit. Okay. So for number one, liquid water freezes. So yung liquid, nag-solidify siya into solid, naging ice. So from liquid to solid, how do we interpret this? Naging positive ba ang entropy or naging negative? Naging mas disordered ba siya or nagiging mas ordered siya? So liquid water freezes. Since mas naging maayos yung kanilang mga particles, then number one is negative entropy. Number two, so naphthalene balls sublime. Yung naphthalene balls, they undergo sublimation wherein from solid naging gas siya. So based on our statements here, ano siya, positive or negative? So from solid to gas, nandito siya. Solid to gas, so this is positive. Number 3, nitrogen dioxide will produce nitrogen monoxide and oxygen gas. So sa number 3 naman, isa yung ating reactant, naging dalawa yung product. So kapag mas marami yung product kaysa sa reactant, ibig sabihin mas gumulo, mas dumami. So that means mas mataas ang entropy. So therefore, positive ang ating entropy sa number 3. Number 4, water, which is liquid, will react with sulfur dioxide, which is a gas, to produce hydrogen sulfide and oxygen gas. Now, tignan natin yung mga states of matter nila. Sa reactant, liquid tapos gas. Sa product, parehong naging gas. So, kagaya ng sinabi natin kanina, mas mataas ang entropy sa mga gases as compared to liquid. So, dito, mula sa liquid, naging gas, kaya naging positive. Our entropy for number 4 is positive. Maliban dyan, bilangin natin yung sum ng number ng mole ng reactant at product. For the reactant, dalawa, so 4 ang number of moles sa reactant. Sa product naman ay dalawa, tatlo, kaya naging 5. So, mas mataas ang number of moles sa product. So, therefore, we can say that the entropy value is positive. Number 5, carbon monoxide gas plus oxygen gas to produce 2 moles of carbon dioxide. So, from 2 reactants, nakabuo siya ng isa lang na product. So, we can say that the entropy is negative. Mas marami yung number of molecules. Samantalang nung nagkaroon na ng chemical reaction, mas bumaba yung number of molecules sa number 5. So, this is negative. So, let's check our answers. Number 1 is negative. Number 2 is positive. Number 3, positive. Number 4, positive. Number 5, negative. So, like total energy, which is E, and enthalpy, which is H, entropy is a state function. So, meron din tayong computation in order to determine if the entropy is positive or negative. This is to check if our assumption is correct. So, the formula is delta S, delta means change, S is for entropy, is equal to the entropy of the final substances minus the entropy of the initial substances. Or, para mas madaling intindihin, the delta S is equal to the summation of the entropy of the products minus the summation of the entropy of the reactants, where delta S is the change in entropy. S final is also referred to as the summation of the total entropy of the product. S initial or the summation of the total entropy of the reactants. Now, paano natin i-compute kapag hindi natin alam yung values? There are assigned entropy values for each of the different substances. These are the entropy values of some of the most common substances. And then we can use the values dito kasi ito yun, no? Ito yung entropy values. Ito yung enthalpy value. We're going to discuss enthalpy values and how to compute for the enthalpy on a later video. So for now, we're going to focus on the S or the entropy values. So nandito. Let us have an example in order for us to determine the total change in entropy of a reaction. The first step is for us to balance the chemical equation. So, in order to balance that, nilagyan natin siya ng mga coefficients. Next is, we are going to substitute the values in accordance to the formula. So, delta S is equal to the summation of the entropy values of the products minus the summation of the entropy values of the reactants. So, for the summation of the entropy of the products, okay, ganito ang gagawin natin. Alamin natin kung nasaan yung reactant at kung nasaan yung product. So, kung saan nakapoint yung arrow, yun yung product. So, that means in this chemical equation, ito yung ating product. Ngayon naman, we have to multiply the value of mole to the entropy value of the substance sa lahat ng mga different substances doon sa product. Saka natin ipag-add lahat-lahat. Okay. So, dito, kukunin natin yung value ng mole ng KCl and close natin siya sa parenthesis. So, 2 times the entropy value of KCl, which is solid. Kailangan natin tignan kung ano yung state. Kasi there are instances na kung saan pare-pareho yung substances pero magkakaiba sila ng state. Kapag iba-iba yung state nila, then iba-iba rin yung kanilang entropy value. So, hanapin natin yung value ng KCl na solid. So, KCl na solid is 82.6. So, 2 times 82.6. And then, i-close uli natin siya sa parenthesis. Plus, yung susunod naman na substance, which is yung oxygen. Yung coefficient ng oxygen, which is 3, times the entropy value of oxygen na gas. So, oxygen gas is 205. So, 205. And then, enclose sa parenthesis. So, the summation of the entropy value of the product is 780.2 joules per Kelvin. Bakit joules per Kelvin? Kasi mole yung unit ng ating coefficient, tapos may mole dito, cancelled, kaya joules over Kelvin lang ang may iwan na unit. Next, for the summation of the entropy values of the reactants, isa lang ang ating reactant, which is KClO3. Ang kanyang state ay solid. So, 2 times, bakit 2? Kasi yun yung coefficient ng KClO3 or potassium chlorate. Hanapin natin ang entropy value ng KClO3. It is 143.1. So the summation of the entropy values of the reactant is 286.2 joules over Kelvin. Cancel uli ang mole. The last step for us to do is to minus the value of the reactant doon sa product. For the product, it is 780.2 joules over Kelvin minus the reactant, 286.2 joules over Kelvin. So therefore, our total change in entropy is positive 494 joules over Kelvin. If the total change in entropy is positive, then we can state that the entropy is positive. Ibig sabihin, magiging mas magulo, magiging mas makalat. Another example, hydrogen sulfide plus oxygen gas to produce water and sulfur dioxide. First step uli, balance the chemical equation. So we have given them the following coefficient in order to balance the chemical equation. Next, ito na yung kanilang mga entropy values para di na tayo mahirapang maghanap. In our quizzes or exam, given na ang ating entropy values para hindi na kayo mahirapang maghanap. So this is our formula. The total change in entropy is equal to the summation of the entropy values of the products minus the summation of the entropy values of the reactants. So unahin natin ang entropy value ng product. Ito uli ang product natin. So water and sulfur dioxide. So unahin natin si water, 2 ang kanyang coefficient times yung ating entropy value ng liquid water. So liquid water is 69.9. So times 69.9. Enclose that in another parenthesis. And then plus yung next substance natin, which is sulfur dioxide. 2 ang kanyang coefficient times the entropy value of sulfur dioxide, which is 248.1. Enclose in another parenthesis. So therefore, our entropy value for the product is 636 joules over Kelvin. Cancelled uli ang moles. Next, the entropy value of the reactants. So ito uli yung reactants natin. Unahin natin si hydrogen sulfide. So dalawa ang kanyang coefficient times the entropy value of H2S, which is 205.8. Plus the next substance, which is oxygen gas. So 3 ang kanyang coefficient, kaya 3 yung ilalagay natin dito, times the entropy value of oxygen, which is 205.2. So this is equal to 1027.2 joules over Kelvin. Next, isubtract natin ang entropy value ng reactant doon sa product as called for in this equation. So product, itong 636, reactant itong 1027.2. Our change in entropy is negative 391.2 joules over Kelvin. So since this is negative, ibig sabihin itong reaction na to ay mas bababa ang disorderliness. Dahil mas bababa ang disorderliness, masasabi natin na ang ating reaction dito ay negative entropy. So that's it for module number 15. You can now work on your modules.